doing some non-linear equations, and I told you like substitution and elimination are still legal. So what would you do here? Elimination, probably. Which one do you want to eliminate? Okay, so you would take the first equation times. So I get negative 3x squared minus 3y squared plus negative 15. Didn't change the second one. When I add negative 3x squared plus 4x squared, y squareds cancel, equal negative 4. Right, now what? With that plus and minus, what's the square root of negative 4?
2i. Plus
Or minus 2i. So currently, I have two solutions. X could be 2i or x could be negative 2i. We have to plug those in to get y. So if x is positive 2i, what is 2i squared? Becomes 4i squared, which is negative 4. Okay, so if I add over my 4, y squared equals 9. Square root plus and minus, so y equals. So what does that mean? X could be 2i and y could be positive 3, or x could be 2i and y could be negative. Alright, we also have the possibility that x is a negative 2i. What's going to happen when you do that? Should give us the same thing. If you recognize that, you don't have to work it out. Negative 2 times negative 2 is positive 4. I times I is I squared, so we're still getting the negative 4. So y is plus or minus 3 again. So we get a total of 4 points here, but they are imaginary, and we can have that. So that was the last one on yesterday's assignment, so that's why I haven't collected it yet. We're going to finish that today, but I wanted to do an example where you had an imaginary. Any questions about that? I want to keep moving on through these sections, but I did print the notes for you today because we're going to look at some of those problems. Alright, we may or may not do all of these. We'll just kind of see what we remember from before. But we're starting with a situation, and we are going to create a system of equations to go with this. Kind of like the past. If I give you a word problem, first of all, you have to make sure you're defining your variables. You can't have x and y in a problem if we don't know what x and y are. And at the end, how do we have to answer it? With the sentence. I have to know what your answer is. Okay. In the 2006 Winter Olympics, the total number of medals won by Germany and the United States was 54. Germany won 4 more medals than the US. How many were won in each country? So what are my variables? And what do they represent? Okay. So I'm going to say X is the US and Y is Germany. And you could flip those. That's why we label them. What would my first equation be? Okay, because I know the total, so altogether was 54. Okay, second one. Germany, so my Germany was Y, won 4 more than the United States. So how would I write that? Okay, two options I heard. I heard y equals x plus 4, and I heard y minus 4 equals x. Are those the same? Yep, so it doesn't matter. Either one will get us there. All right. Now what do we need to do? Solve it. So this one is set up, let's do substitution, just for fun. So I have x plus, if I wrote it the first way, y is x plus 4. X plus 4 equals 54. Means 2x equals 50. And x is 25. And then we can plug that back in. Y was equal to x plus 4. So y is 29. And then what do I do? US 125 and Germany 129. Questions on that? Let's take a look at the next one. I want you to take a second, read it to yourself, and see if you can at least identify what our variables should be. What's it asking me? How much should be placed in each investment? So those have to be my variables. What are the two different investments we are making? Right. We have the government insured one, that's 8%, and the non-insured one, that's 12%. 9% is our goal, right? That's what we want, but we're investing some at a lower one and some at a higher one in order to get an average of 9. So you can label X and Y however you want. You could say insured and non-insured. You can use the 8% or 12%, however you want. So it's the amount of money I'm investing in each of those things. So the first thing I know is we have $70,000 to invest. So what would my first equation be? Okay. Now the second one, we have to think a little bit more. It's talking about our interest. X is the amount I invested at 8%. So how would I find my interest from that? U times 8% is so 0.08x plus for my y 0.12y equals, okay, how much interest am I trying to get? 9% of my 70,000, right? So to figure this out, I have to think 70,000 times 0.09. 6,300. So that's where that number comes from, 9% of my total. All right, we've done the hard part. We find our variables, write our equations. Now it's just a matter of substitution and elimination. Which would be easier here? I would say elimination, substitution, it really doesn't matter. If I wanted to eliminate x, what would I multiply the first one by? 600. Didn't change my second equation. And if we add together the x's cancel, 0.04y equals 700. And then we can plug that back in to get our x. And then what do we do? So Sarah should invest $52,500 at 8% and $17,500 at 12%. Do we need another interest problem? Let's do one more. Linda won $200,000 in a state lottery. She first paid income tax of 30% on the winnings. Of the rest, she invested some at 1.5% and some at 4% to get $4,350 interest per year. How much did she invest at each rate? Okay, this one is slightly different. We're trying to find the two rates, so our variables, x and y, what would they represent? But my first equation, did she invest $200,000? No, she paid taxes on it. Yes. To find the amount of tax, you can take your $200,000 times 0.3. So we paid $60,000 in taxes, so you never even got that much. So how much money does she actually have to invest? So to find what remaining, just take your starting amount minus what you paid out in taxes. Okay, so we did have the extra step here that we paid taxes first, we had to figure out how much money we have left. But now our setup is similar. So we have $140,000 to invest. Okay, X is the amount at 1.5%. So what would I do? Let's go on 5X. Y is the amount at 4%. Equals, how much interest did we get? So this time I did tell you the total interest. x. What do we multiply by? Yeah, our x's cancel. Y is negative 0.015 plus 0.04. 0.025 equals 2250. 90,000. I did negative 0.015 plus 0.04. You okay there? Since that one's a negative, you're subtracting. Okay. Once you have y, you can plug it in. So x is 50,000. So she invests 50,000. 1.5%. 90,000. 4%. Questions on that one? I want you guys to, I'm going to skip to this one, so skip the next one, go to this one. I want you to read it and see if you can set it up and write your two equations. That sells for $3 a pound, with 3 times as much tea that sells for $2.75 a pound, to produce a mixture worth $112.50. How many pounds of each type of tea does the merchant use? So what are my variables? And what do they represent? Okay. Now, I need my equations. One thing I'm given is all of these dollar amounts. So how would I write that equation? So if I'm going to get the cost, I have to take the cost times the number of pounds. So 3x plus 2.75y equals $112.50. So you take the number of pounds times the cost per pound. Are we okay there? What else have I told you? So the tea that sells for $3 a pound, that's X. And I'm blending that with 3 times as much of the one that sells for Y. So how am I going to do that? Say that again. Okay, we have a 3Y, 3 times as much. So is this set up correct? Why are you shaking your head?
You don't have the same amount? Because it's 3 times this one as the X.
Okay. The Y, I have more of the cheaper T, right? So the amount of my cheaper T, my Y, is equal to 3x. We need to flip it. In order for them to be the same, I'm saying I have 3 times as much of the cheap T. Okay, so if I had 6 pounds of the cheap tea, then my other one is just 2, right? So you have to take the more expensive one times 3 to get that one. Okay, that one was worded a little bit weird. What would it be our best option for solving this? Yeah, you could do either. If you just multiply by a negative, it's set up for elimination. But I'm just going to go ahead and replace my y with my 3x. I think that will be really, neither way is going to be too bad. Okay. So if we calculate, this would be 8.25 plus my 3. My x is 10. My y is 3 times as much, so y would be 30. So there should be 10 pounds of the $3 tea and 30 pounds of the $2.75 tea. Any questions? I'd like to do just one more thing. So yesterday we solved systems with 2 equations, both linear and nonlinear. We can solve a system with more than 2 equations. The amount of work required goes up quite a bit as you add more equations, so we're not going to do more than 3. But I wanted to kind of look at 1 or 2 examples of these. Let's see how we're doing on time. And see, our strategies are the same, substitution or elimination. But what we're going to do is actually work with 2 equations at a time. Elimination is probably going to be a little bit easier here. So our best strategy is you take 2 equations and you eliminate a variable. Okay, so if I take my first 2 equations, what variable do you want to eliminate? Z. So what would I have to take first one times 2? So if I add this together, you get 6x minus y equals 14. I can't solve this yet, but I took 2 equations and I got rid of the z. Now what we need to do, we have not used the third equation yet, so I'm going to use the third equation. I'm going to pair it with one of the others, and I need to eliminate the same variable, so I have to get rid of z again. So if I want to use the third equation and get rid of z, what other equation would you put it with? First one. If I want to put those 2 together to get rid of z, what are we going to multiply by this time? Negative 3x minus 3y plus 3z equals t. did the first and second and got rid of z. Now I'm doing the first and third and getting rid of z. Add those together, I get negative x minus 5y equals 8. How does this help me? We now have two equations that have two variables. Can I put those together? If we wanted to eliminate something, what would I need to do? Let's do negative 5. Right now, these together. Divide and I get x to equal 2. Now what do? Plug it back in. Don't go to the originals yet, because the originals had 3 variables, right? But if I plug it into one of my highlighted yellow equations, those only have 2 variables, so I could put it in there. So if I put it into this 6x minus y. 6 times 2. And once I have x and y, go back to one of the original. I'll just go with the first one. When you write your answer, it's always alphabetical order, so x, y, z. 2, -2, 1. And we can check them just by putting it into the equations. So you can see adding this third equation really increased our work. There are other methods for solving those when you get more equations, which hopefully I have time to introduce you to before the end of the semester, but we'll see if we do or not. But do you guys understand how we got here? You want to do another one of these? Okay, let's do this. Stop for today. You have the homework from yesterday. We had question number 8 we didn't do yet, so you need to do that. And then I posted a second handout with 5 questions for today. Okay, so let's work on this, and then at the end of the hour, I kind of want to talk to you and see where we're at, if we're doing good or if we need one more day. Okay?